Chapter 8, Section 1, Describing Chemical Reactions. So this topic talks about chemical reactions. So, chemical reaction is a process by which one or more substances are changed into different substance. So here the key word in a new substance formed. So in chemical reactions, a new substance formed. For example, shredding paper or burning paper. So in this change, no new substance formed. So it's a physical change. But when you burn paper, so new substance formed. So it's a chemical change. So any change that produces a new substance, it's called a chemical change or chemical reactions. So now, indicators for chemical reactions. The first one, evolution of energy as heat and light. So for example, when you burn magnesium, the products are magnesium oxide plus energy as light. So for example, here, burning of magnesium.
There we go.
So energy is produced, energy as light, as you can see.
I don't know if that's toxic, so I'm not going to go in it. You can see it's twinkling, making some little sparks. Very bright to look at. So I'm looking at it on the screen. That helps a lot. Not going to burn for long. It'll be out in a few seconds. This is a good product, especially for starting fires.
Okay, so now
I'll make another video.
the second one, production of gas. For example, when magnesium reacts with hydrochloric acid, so the products are magnesium chloride plus hydrogen gas. So if any reaction or in any change, if gas is produced, so it's an indicator for chemical reaction or chemical change. So here you have to balance. For example,
sodium bicarbonate, and
they
see what
add
happens
sodium
to the
bicarbonate
relative amount of gas that's
to
produced
acetic
or the
acid.
size of the balloon.
Carbon dioxide produced and fill the balloon. Another reaction, carbon dioxide gas produced.
So after this reaction has completed
Okay.
here, we can see that the relative...
The third one, formation of precipitate. So for example, if you have two solutions like sodium chloride added to silver nitrate, they are solutions. When you add it to each other, the products are sodium nitrate and white precipitate AgCl. It's a white precipitate. So if you have two solutions and when they added to each other, precipitate formed, so it's an indicator for chemical reaction. Here, for example, they add sodium chloride,
also known as your salt water,
to silver
the silver
nitrate.
nitrate solution, and there you see
Yeah.
your precipitate.
white precipitate.
Ooh, gross. Now the question that we immediately want to ask is, what is this white stuff?
Number 4, color change. But you have to know that it's not a strong indicator for a chemical reaction. So again, chemical reaction is the process by which one or more substances are changed into different substance, so new substance formed. So in any change, if no new substance formed, it's a physical change. If a new substance formed, it's a chemical change. Indicators for chemical reactions: evolution of energy as heat and light, color change, production of gas, and formation of precipitate. Now, to summarize the chemical reaction, you have to use chemical equation. So, chemical equation summarize the chemical reaction. There are two types of chemical equations: formula equation and word equation. So from its name, word equation, so reactants and products are represented by words. For example, carbon plus oxygen produced carbon dioxide. So it's a word equation because reactants and products are represented by words. Now what about formula equation? In this case, reactants and products are represented by their symbols or formula. So for example, for this reaction, the symbol for carbon is C plus oxygen gas, O2, to produce carbon dioxide gas, CO2. So, there are two types of chemical equations. Word equation, you have to use words, and formula equation, you have to use formulas or symbols of elements or compounds. Now, general formula for any chemical equation is reactant or reactant, then arrow, then product or product. So substance before arrow, they are the reactants, and substances after arrow, they are the product. There are some symbols used in the chemical equation. You have to know these symbols. So symbols used in chemical equation. So this arrow means yield or produced. If you have reaction with two arrows, it means reversible reaction. Reversible reaction means after the reactants, here reactants and the products, after the reactants produced product, then the products react with each other to form reactant again. So if you have substance with this symbol, it means solid state. If the symbol is G, so it's a gas state. If L, it's liquid state, like water. But if you have AQ, AQ means aqueous solution. Aqueous solution means dissolved in water and form ions. So for example, when table salt and ACl dissolved in water, it's an ionic compound, so it dissociates to ions, so we add this symbol AQ, dissolved in water and form ions. And the last one, if you have arrow and triangle, this triangle means heat. So this reaction needs heat to occur. Now, examples about word and formula equation. Now here the question. Write word and formula equation for the chemical reactions that occur when solid sodium oxide is added to water at room temperature and forms aqueous solution of sodium hydroxide. So you have to write word equation. Again here in the question, solid sodium oxide is added to water. So the reactants are sodium oxide and water. So here, sodium oxide added to water. So what are the products in the question here? And forms aqueous solution of sodium hydroxide. So here, sodium hydroxide. This is a word equation. Now, formula equation. What is the formula for sodium oxide. You have to remember from chapter 7 section 1 how to write the formula. If you remember, sodium, the symbol of sodium Na, it's in group 1 in the periodic table, so it's carry positive 1. Oxide, it's for oxygen, it's in group 6 in the periodic table, so carry charge negative 2. So you have to multiply sodium by 2 and oxygen by 1. So the formula of sodium oxide is Na2O plus. What is the formula of water? H2O. To produce sodium hydroxide. Sodium, Na, it's in group 1, positive 1. Hydroxide, it's a polyatomic ion with charge negative 1. When positive charge equal to negative charge, they cancelled each other, so the formula is NaOH. You have to know that in formula equation, you have to write the state for each substance. So from the question, solid sodium oxide. So here the state is solid. Water, the state of water, liquid, you have to know. And here, to form aqueous solution of sodium hydroxide. So here, AQ. Okay. What about this equation? It's a correct equation. Here, you have how many sodium atoms? 2. But here in the product, you have 1. How? So you have to know that any chemical equation must satisfy the law of conservation of mass. This law states that total mass of reactants must be equal to total mass of products, or number of atoms of each element in the reactant must be equal number of atoms of each element in product. Now here you don't have equal number. Here you have 2 sodium atoms, but here 1. So how to make number of atoms of each element in the reactant equal to number of atoms of each element in the product? So you have to multiply the element or compounds by coefficient. This coefficient is in front of compound to get equal number. So here you have 2 sodium atoms in the reactant. Here you have 1. So it must be 2. You have to multiply this compound by 2. This number, which is called coefficient, it's in front of compound 2. And it's for each element in the compound. So this 2 for sodium and oxygen and hydrogen. So here, according to number of sodium atoms, it's equal 2 sodium atoms in the product, in the reactant, and here 2 sodium atoms in the product. What about oxygen? Here in the first reactant, you have 1 oxygen atom, and in the second one, 1 oxygen atom. So the total number of oxygen atoms in the reactant are 2. So here you have 2 oxygen atoms. Again, this coefficient for each element in the compound. Okay, so for oxygen, it's equal. Now what about hydrogen? Here you have 2 hydrogen atoms in the, in the reactants, and here you have 2 hydrogen atoms in the product. So now it's a correct equation. So again, when you write formula equation, you have to know that you have to write the states of each compound or element, and after you write the equation, you have to balance the equation. How to balance the equation? By multiplying with coefficient. This coefficient is in front of compound and for each element in the compound. So another example. Now, write word and formula equation for the following reactions. So the first one, solid magnesium and aqueous hydrochloric acid react to produce aqueous magnesium chloride and hydrogen gas. Okay, so what about word equation? Reactants and products are represented by words. So solid magnesium and aqueous hydrochloric acid. So the reactants are magnesium and hydrochloric acid. React to produce aqueous magnesium chloride and hydrogen gas. Magnesium chloride and hydrogen gas. So now, how to write formula equation? What is the symbol for magnesium? It's Mg plus hydrochloric acid, HCl, to produce magnesium chloride. Magnesium, the symbol Mg, it's in group 2, so positive 2, and chlorine is in group 7 in the periodic table, so negative 1. So what is the formula of magnesium chloride? Mg by 1, so Mg, and Cl by 2, Cl2, plus hydrogen gas. What is the formula for hydrogen gas? It's hydrogen? No. Hydrogen gas, it's a diatomic molecule, H2. So you have to know that some elements exist as diatomic molecules, like diatomic molecules, like hydrogen, H2, state is gas, nitrogen, N2, oxygen, O2, fluorine, F2, chlorine, Cl2, bromine, and iodine. So these elements naturally exist as di, it's related to number 2. So they exist as diatomic molecule. So in an equation, if the product or reactant hydrogen, you have to know it's H2, nitrogen, N2, oxygen, O2. So here again, hydrogen gas, H2. So in formula equation, you have to write the state. Here, solid magnesium, so S, and aqueous hydrochloric acid, so AQ, to produce aqueous magnesium chloride, so AQ, and hydrogen gas. So after you write any equation, you have to balance or to check if it satisfies the law of conservation of mass or not. So here you have in the reactant 1 magnesium atom, in the product 1 magnesium atom. So according to number of magnesium, it's equal for reactants and product. Now what about hydrogen here? You have 1 hydrogen in the reactant, and here you have 2 hydrogen atoms in the product. So it must be equal to each other. You have to multiply by coefficient to get equal number. Here you have 2, so this must be 2. How? By multiplying by coefficient. It's in front of compound and for each element in the compound. See, so here you have 2 hydrogen atoms and in the reactor and product 2 hydrogen atoms. Now what about chlorine atoms? Here you have in the reactants 2 chlorine atoms and in the product 2 chlorine atoms. So it's a balanced equation. Another question. Aqueous aluminum sulfate and calcium hydroxide solution react to produce solid aluminum hydroxide and solid calcium sulfate. So now how to write word equation. Again, aqueous aluminum sulfate and calcium hydroxide. So the reactants are aluminum, sulfate, and calcium hydroxide. What are the products to produce solid aluminum hydroxide and calcium sulfate? So aluminum hydroxide and calcium sulfate. So now you have to write formula equation. What is the formula for aluminum sulfate? Aluminum, the symbol for aluminum Al, it's in group 3 in the periodic table, so positive 3. Sulfate, it's a polyatomic ion, SO4, and the charge is negative 2. So you have to multiply aluminum by 2 and SO4 by 3 because it's a polyatomic ion, so you have to put it in between brackets, so by 3 plus calcium hydroxide. Calcium, it's in group 2 in the periodic table, so positive 2. Hydroxide, it's a polyatomic ion with charge negative 1. So you have to multiply calcium by 1 and hydroxide by 2 because it's a polyatomic ion, so you have to put it in between brackets to produce aluminum hydroxide. Again, the symbol of aluminum Al, it's in group 3 and hydroxide polyatomic ion with negative 1. So the formula is aluminum OH Al OH by 3 plus calcium sulfate. Calcium, it's in group 2 and sulfate, it's a polyatomic ion with negative 2. If positive charge equal to negative charge, they cancel each other, so the ratio 1 to 1. Now you have to write the states for each compound. Aqueous, here aqueous aluminum sulfate. So aluminum sulfate AQ plus aqueous aluminum sulfate and calcium hydroxide solutions. So here also calcium hydroxide, it's an aqueous, to produce solid aluminum hydroxide and solid calcium sulfate. So the products are solid. Now after you write any equation, you have to balance. Here in the reactant, you have 2 aluminum atoms. Here in the product, you have 1. Must be equal to each other, so you have to multiply by 2. Now, SO4 group, it's all multiply by 3. So here you have 3 groups of sulfate. In the product, you have 1 group of sulfate. So it must be 3. So you have here to multiply by 3. Now, calcium. You have 1 in the reactant, 1 atom of calcium. And here you have 3. So here you have to multiply by 3. Now, hydroxide group. Hydroxide group. You have 2 and it's multiply also by 3. So how many groups of hydroxide? You have 6 hydroxide group. So here in the product, hydroxide group, it's multiplied by 3 and by 2. So also here you have 6 hydroxide group. So now it's a balanced chemical equation. Now the last questions about balancing the chemical equations. For example, potassium plus water to produce potassium hydroxide plus hydrogen gas. How to balance this equation? Here in the reactants you have 1 potassium atom and here 1 potassium atoms. Now for hydrogen, here you have 2 hydrogen atoms and here in the product you have 1 and you have here 2. So the total is 3. So now if you have odd number, here 2 and here in this compound 1. If you have odd number, multiply by 2 to get even number. So here you have 2 hydrogen atoms and here 2 hydrogen, so the total is 4. So now in the reactants you have 2. How to get 4? By multiplying by 2. Now for oxygen, you have 2 oxygen atoms and here 2 oxygen atoms. What about potassium? Here you have 2 potassium atoms and in the reactant 1, so you have to multiply by 2. So now you get balanced chemical equation. Another example, iron plus chlorine gas to produce iron 3 chloride. Here in the reactant you have 1 iron atoms and here in the product you have 1 iron atoms. Now what about chlorine? In the reactant you have 2 and in the product 3. So how to get an equal number for chlorine? So in the product you have to multiply by 2, so you can get 6 chlorine, and in the reactant multiply by 3, so you can get 6. So here multiply by 2 and here multiply by 3. So according to number of chlorine atoms in the reactants, here multiply by 2 and multiply by 3, so 6. Now what about product? Here multiply by 3 and multiply by 2, so the total is 6. Now what about iron atoms? In the product here you have 2 and in the reactant 1, so multiply by 2, so now you get balanced chemical equation. The last example, copper plus silver nitrate produced copper 2 nitrate and solid silver. Now here in the reactants you have 1 copper atoms and here 1. Now 1 Ag atoms and here 1. What about nitrate group? Here you have 1 nitrate group and here you have 2 nitrate group. So you have to multiply by 2. So number of silver atoms in the reactant 2 and here 1, so multiply by 2. So for copper 1 to 1, silver 2 to 2, and nitrate group, this nitrate group is multiplied by 2 and this nitrate group is multiplied by 2, so it's a balanced chemical equation.